right, AP Stat, this is your example 2 on your linear regression notes. So I'll try to get through this one quicker than the last one. I didn't realize it was taking a whole 11 minutes. Oh my goodness. All right, so this one's a little different. We don't have data this time. We have some computer output, and the scatter plot and the residual are already given to us. So for this particular set of data, the information that I'm going to need for my computer output are going to be the constant right here. Guess what? The word constant implies y-intercept because in your equation, your y-intercept is your constant. It's not right next to x like the slope is. So this is your y-intercept. And then, of course, diameter is right here. And if you'll notice down in your scatter plot picture, diameter is right here. That means that's the x. Well, the value associated with the explanatory variable, of course, is the slope. All right. So as we look at this, in part A, we're asked what is the correlation, and using the scatter plot and R, describe the relationship. Well, if you'll notice on here, I've got an R squared, see that SQ right there? And then I've also got an R squared adjusted. We don't ever use the adjusted R squared. We only look at this R squared, so it's important that you pay attention to that. Well, if R squared is 67.1, then R is going to be the square root of that. So to find R, I'm going to take the square root of 0.671. I have to use the decimal, not the percentage. So I move that decimal over twice, and this gives me 0.82. So using the scatter plot and R, describe the relationship. Well, as you can see, in your scatter plot, we do have a couple of values that are kind of off the trend here, but overall, it's got a pretty linear distribution, and the R is pretty close to 1. So this would still be considered a strong relationship. So I'm going to write, there is a strong, and it is in the positive direction, so a strong positive association. You can also use the word relationship. Only make sure that you remember all your words. This does have a linear look to it, so linear association or relationship. So there's a strong positive linear association between height and tree diameter with a couple of possible outliers. It looks like this ordered pair right here is about 16 something, maybe 16.5. I wouldn't try to ballpark it any closer than that, like 16.23 or anything. Don't get crazy. Too late, Miss Griggs, you're already crazy. I know, right? I know. And the other ordered pair would be right up here at about 14.5 and 85, something like that. And I know it may seem trivial to you to try to guess what those ordered pairs are, but I've seen that happen on the AP test before, so just throwing it out there. All right, so part B, give and interpret the slope. Well, the slope is, you know what? I used the wrong letter. The slope is 1.4001, and how do I interpret that? Well, as a tree's diameter increases by 1 inch, I can expect its height to increase by about 1.4001 feet on average. Yay! Okay, give and interpret the y-intercept. Well, A is equal to 58.9887. So, this seems a little awkward, but we're gonna talk about that. If a tree has a 0-inch diameter, I expect its height to be about 58.9887 feet. But I'm just going to add this in. You don't necessarily have to do this, but it might be one of those situations where you're asked kind of a common sense question. I'm just going to add here, but it seems unlikely. Unless you've seen some really, really special weird trees. I don't know. But almost 60 feet is really tall. It's quite tall. And a tree would need a bigger diameter than 0 inches. So, just throwing that out there. Sometimes you will be asked if it makes sense, if the interpretation makes sense. And that's the only one, that y-intercept interpretation, that's the only one that sometimes doesn't make any sense. It's just weird. All right, so part D, we're going to write the equation. So I'm going to write predicted height equals the y-intercept plus the slope times the diameter. Groovy. Okay, give the coefficient of determination and interpret its value. Well, r squared, we already found from our computer output, it's 67.1%. If you're going to write it in percent, don't forget your percent sign. 67.1% of the variability in tree height can be explained by this linear model. All right, part F. Oh, and to expand more on the coefficient of determination, this means that 67.1% of our variability in our tree height, so how tall the tree gets, 67.1% of that difference, how that varies, can be attributed solely on its diameter. All right, there are lots of other factors. It could be weather. It could be attributed to, an increased presence of man near the trees. I mean, who knows? It could be due to all other kinds of things. All right, so refer to the residual plot and describe what it indicates about the relationship. Well, I've got my residual plot right here, and it doesn't appear as though there's an overall linear pattern or an overall quadratic pattern or anything like that. So I think it's perfectly acceptable to say that it is scattered about the x-axis. So the linear model is a good fit for the data. Another way to think about this is that a linear model would be appropriate for the data. That word comes up a lot. All right, so if I'm predicting the height of a tree with a diameter of 11, I am going to find my height, my predicted height. I know I'm using the symbol now. It's just to cut this back. This is already too long. Sorry, kids. These problems take a long time. And I feel like I need to explain as I go along, because I'm a teacher. So 74.3898 feet approximately. Okay, now we're being asked to use our prediction to find the residual at 11 inches. So the residual would be equal to the actual y value, which for 11, so I'm going to look at 11 right here, find that point. That's about 75. So 75 minus the predicted value, which is right up here, 74.3898, and that equals 0.6102. So what does the residual mean in context of this? Well, what it means is that my predicted value actually falls below the actual value of the tree I measured at 11, at a diameter of 11. So that just means that the line, my prediction line, under-predicted what was going to be the height of that tree. So have fun with it.